artifact rejection. In artifact rejection, we actually take the segment of data that contains the artifact and we just literally throw away that segment of data. Artifact removal is almost like a filtering technique. It's not filtering in the traditional sense because, of course, as we said, the artifacts share frequency space with the data, so we can't, use like a bandpass filter to get rid of the artifact. But there are other techniques that people do use for artifact removal. So we are not looking at an extensive number of these in this class. We do a little bit more of this in biomedical signal processing. A person could do an entire course on EEG artifact removal because there are a number of techniques. It has been and continues to be a very active area of research because, as I said before, a person really does not want to just throw away all of the artifact contaminated data that they have in an EEG data set. You would end up with very little data. So what you'd really like to do is come up with some way of removing the artifact from the data without rejecting the data segment. So one common method that's used is the wavelet method. Here, the wavelet function itself is used as a filtering function. The signal is broken down into wavelet subbands, so it's very similar to using a series of bandpass filters and breaking signal down into frequency components, except in this case you're looking at the wavelet transform and you're looking at the transform for a particular scaled function. So if you have a wavelet function whose shape corresponds well to the artifact, then you will get a level of wavelet decomposition that is very well matched to the presence and or absence of artifacts. So if that's the case, you can literally come in and zero out that wavelet coefficient in the wavelet domain, very much like you would use a filter to zero something out in the frequency domain. Then you can take the inverse wavelet transform to restore the data without the artifact. So this is pretty effective on eye blink artifacts. That's what it's mostly been used for. The wavelet functions seem to be pretty good at picking that up, mostly because eye blink artifacts tend to have a fairly repetitive shape. And so that shape, if you can pick a good mother wavelet function, that shape tends to correspond on a fairly regular basis to a particular scale of that function. So a lot of research done on using wavelet methods to remove artifacts from your data. The other really hot area is independent component analysis. So independent component analysis, we'll talk more about independent component analysis later. Right now I just want to say that it's a blind source separation technique. This means that you have a multivariate data set. So you have channels of data, and you know that these channels of data represent a superposition of some independent sources, some of which would be your artifact sources. So you basically do a matrix transformation that is designed to optimize linear independence of those sources or components that make up that superposition-based signal. So you use a matrix transformation to separate out the sources. And then you identify the sources that are consistent with your artifact. So you can actually, after you run ICA, you can actually look at what the components look like. The ones that look like the eye blinks can be thrown away, and then the matrix transformation can be inverted, and you can generate your original data set, hopefully without the artifacts. So independent component analysis is kind of the magic bullet right now for artifact removal without having to reject large segments of the data. We will devote a special lecture to independent component analysis and removal of artifacts as a part of looking at EEG Lab, and there are also EEG Lab lectures on how to do this. It is kind of an art in addition to being a science, because you do have to be able to identify which are the artifacts that you would like to throw away, because clearly if you throw away the wrong one, you've thrown away some of your meaningful data. So this does not completely solve the problem of artifact rejection or artifact removal, excuse me, but it does at least provide a method to get rid of some of the more significant artifacts.